welcome to another math tutorial. This video we're going to go over linear modeling. So how to take real world data and create a linear function that is going to model that data that we're going to then be able to use to predict future values kind of along that line. Let's get started with some vocabulary and then we're going to dive right into an example problem. Okay, a couple of vocabulary terms that you're going to want to write down on your notes if they're not already there. The first one is regression. So what we're going to be doing is a regression kind of analysis of the relationship between two different variables. So that's what a regression is. It's the statistical study of the relationships between variables. Now the correlation then is just simply going to be the strength and direction of the relationship between the two variables. So take a moment and pause the video here if you need to record these vocabulary definitions. Okay, so what do we mean by correlation? What kind of types of correlation are there? In other words, like what could happen when we take a set of data and plot that data on a graph? Well, it's possible, I suppose, that if we were to take some bivariate data and plot it on a graph, that maybe we get a graph or a scatter plot that looks something like this. Like what if we just had some points like this that were just kind of scattered everywhere, okay? So that's a possibility. And if you see something like this, that where the points are just kind of scattered everywhere, well, that would be an example of one where there is quite simply no correlation, okay? There's no relationship between the two variables, okay? You know, for example, what if one of the variables was height and the other variable was GPA in school, right? It's definitely conceivable to think that it doesn't matter how tall you are, that is not going to be a predictor of what your GPA in school is. So that might be an example of bivariate data where that might have no correlation at all, or one does not predict the other one. Something else that we might see, maybe we've got some points of data that look like this, okay? Where it's definitely looking like the points are kind of following a line here. They're clustered pretty close together. They're clustered pretty tight together. And in fact, if you look closely, it's possible that you can kind of see a line going through there, okay? So if we saw something like that, we could say that that has a positive correlation, okay? Positive in that the points are sloped in such a way that they are increasing from left to right, which is like a positively sloped line. I could also describe the strength. I could say that this is showing a strong correlation, that the points are really tightly kind of packed or clustered near that line. We might also see something that looks like this. It appears that when I look at this that there is a cluster of points, a little bit different than the prior graph. These points, if I look at them, appear to be going down the graph. You know, so different than positive correlation over here, I could say that these points are showing a negative correlation. And if I were to describe the strength of this correlation, notice that the way I do the points, they're further away from the line than what we saw over here, where they were really tightly clustered around that line. So I might describe the strength of this correlation as being weak, as opposed to being strong over here. So that's kind of the things that we could see. You know, we could see positive correlations that show either a strong or a weak relationship. We could see negative correlations that either show strong or weak relationship between the variables. Okay, this example problem says that anthropologists can use the femur or thigh bone to estimate the height of a human being. The table here shows the results of a randomly selected sample. So if we look at the table, it's titled femur length and height, and then we have the length in this column and we have the height in this column. The units are all in centimeters. Now we're going to begin by creating a scatter plot of this data. Now if you're following along and you have the notes in front of you, you're going to have the table in front of you as you're doing your scatter plot, but I'm going to switch slides to just the graph, and I'm going to be looking at this kind of off camera, but hopefully you've got this in front of you to follow along a little more closely. Okay, the first step of this problem is to make a scatter plot of the data, and then we're going to draw a line of best fit. Now notice that I've got a graph here, but it's not labeled. There's no scale on the X and Y axis as well. So we've got to create all of that from scratch. And because of that, if you are working on an assignment, if you're working on your own problems, it's possible that a classmate of yours has the same exact problem, but their graph might look a little bit different than yours does, depending on how they set up their scale on their graph. So let's go ahead and kind of get started. I'll just walk you through kind of my thought process. It says that anthropologists are using the femur to estimate height of a human being. So to me, the femur is the independent variable that is going to be used to predict the height of the human. And if the femur length is independent, then I'm going to put that on the x-axis. Okay, so my x-axis is going to be femur length, and the y-axis is going to be height. Okay, now I need to determine what I want to make my scale. Now if you go back and look at the table, the length of the femurs range from 27 to 46. So I need to divide up the x-axis in such a manner that it fits 27 to 46. And I would like the points to be kind of scattered throughout the graph. I don't want, in other words, I don't want to go 10, 20, 30, 40, 50 up to 100 and have all the points falling just kind of right in here. I'd like them to be kind of spread out along the graph. So let's see how we could do this. I think if I were to start at maybe, let's see if we can maybe count by threes. If I go with like 24, 7, 30, 33, 36, 39, 42, 45, that's pretty good. I'm going to go ahead and start at 26. And the next would be 29. There's no real right way to do this. I'm going to let you do this how you want to do it. Okay, so that should fit everything going all the way through 46. And the height of the individuals in the sample looks like they're ranging from 131 to 187. That's a difference of about 56. So I think I'm going to need to go by maybe sixes to fit everything in here. I'm going to start at, let's just see if this works first time. We're going to start with 130. I'm just going to count up by sixes. Okay, from 130 to 184, 187 is just going to be just a little bit off the grid here. I'm okay with that. I'm not going to redo this graph just to get that to fit on there perfectly. So now let's go ahead and start plotting some points. We're just going to take all the points one at a time. We're going to put them on the graph. So my first point is 36, 160. So 36 is going to be about here, 160 going to there. Okay. Next point, 32, 143. So 32, 143 lives about there. Next one, 46, 187. So 46 is here, 187, that's the one that's going just a little off the graph. I can live with that. Next we've got 29, 142. Next, 35, 161. Next one, we've got 38, 164. Next, 30, 140. And finally, 27, 131. About like that. So there's my scatter plot of the data. It definitely looks like, if you follow this line, if you can see the line, it definitely looks like we've got kind of a cluster of points here that live on a line. Now we're going to draw a line of best fit. And there are statistical tools that will do this for you. We're going to do another example where we're going to use the calculator to do it. But for this example, we're just going to do it all freehand just to practice and understand the process. So what I'm going to do is try and fit a line that goes as closely through these points as I can. I kind of want some of the points above the line, some of the points below the line. Kind of want to get this line centered through the data. So when you think you've got a good line, go ahead and draw it in there. That's pretty close. If I was doing it over again, maybe I'd push it out just a little bit out, but I think that's pretty good right there. So there's my scatter plot. There's my line of best fit. That's the process as far as setting up the graph, plotting the points, and then dropping a line in those points. Okay, the next thing we want to try and do is write an equation of the line of best fit that we just drew on our graph. Now let's kind of think about and review, what do we need to write the equation of a line? So this was in the previous video, section 1.5 in this chapter's playlist. So what do we need to write the equation of a line? We are going to need a slope and a point on that line. So we need those two pieces, slope and a point. And of course, to find slope, we're going to need 2 points. So let's go back to our graph and let's pick 2 points that are on the line that I drew. Okay, here we are back to our graph. I'm going to pick 2 points that are on this line, and they can be any 2 points that you want. It doesn't have to be points from the table that created the scatter plot. They can be any points that your line goes through. I've got a point right here, right on the grid lines that looks pretty good to me. That point is 41, 172. So I'm going to use that point. I like that one there. And if I come down here, kind of like maybe this point down here, but again, you can pick any point you want. That point looks to be 29, and I'm going to call that maybe 138. Okay, so there's my 2 points. I'm going to use those 2 points to find the slope. Let's go ahead and just do that right here on this slide instead of transitioning back to the other slide. We'll do some of the work right here. So the slope between these 2 points, it's going to be y minus y divided by x minus x. And I have no idea how this is going to work out. We might get some crazy fun decimals here, but let's play with this and see what comes about. 172 minus 138 is 34. And 41 minus 29 is 12. And so I get a slope of, let's see, we can divide everything by 2. I'm going to get 17/6, or I don't want to use a mixed fraction anyway, but we're going to have 2 5/6. So I'm going to go ahead and use as my slope this improper fraction right here. And if you want, I tell you what, it might even actually be easier since this didn't work out super nice. Let's go ahead and use a decimal. This is an approximation game anyway. Let's go ahead and call the slope about 2.83. We're going to use that number in our computations. Okay. Now, we need a slope and we need a point. So now I need to pick one of these 2 points. It doesn't matter which one. I'm going to go ahead and pick this one right here. And let's go back to our other slide. Let's do the work to write the equation. Okay, to write the equation of our line, we're using point slope form of the line. So y minus the y coordinate of the point, which was 138, equals the slope, 2.83, times the quantity x minus the x coordinate of the point. So there's point slope set up. I am going to use a calculator to help with these computations. So let's see, distributing 2.83 times 29, it's going to turn this into y minus 138 equals 2.83x minus 82.07. I'm going to add this 138. So we get an equation of y equals 2.83x plus, let's do the math here on the calculator, 183 minus 82.07 is 100.93. Hold on, it is definitely not 100.93. Let's try the math again. 138 minus 82.07. That looks better. So here's my equation. Let's write it out here. Y equals 2.83x plus 55.93. So there's my equation of my line of best fit. Now we are going to use this equation to make a prediction. Step 3 here, use the equation to predict the height of a human being whose femur length is 22 centimeters. The 22 is going to be inserted into the x of my equation. So y equals 2.83 times 22 plus 55.93. And so if I do that math on the calculator, this time I'm going to try and do it correctly. I get 118.19 centimeters. So our mathematical model, which is this, is predicting that a femur length of 22 centimeters is going to make the height of a human of 118.19 centimeters. Okay, this final example problem, similar to the last one, we've got some information in this table presented. The table is showing the average temperature and rainfall for 8 months in Boston, Massachusetts. We were asked to make a scatter plot of the data, find the correlation coefficient, find the equation of the line of best fit, and then predict the temperature when the average rainfall is 86 millimeters. Okay, so I'm going to attempt to do this one 100% on the calculator, and I'm going to demonstrate every step slowly as I go. And I will just zoom in on the calculator as much as I can to give you enough visible screen to see exactly what I'm doing. So keep the notes out handy, but I'm going to move this away a little bit as I zoom in on the calculator. Okay, the first thing you're going to want to do to make a scatter plot of the data is you have to enter the data that's in the table onto the calculator. And so the way to do that, I'm going to describe the buttons down below the screen, but I want you to be able to see the screen. So I'm just going to tell you what I'm pressing. On the calculator, there is a button that says Stat. It's kind of center of the calculator. Hit that button and it pulls up a menu like this. We went to Edit, is how we're going to type in the data. And so it should pull up a screen that looks like this. Now, if there are any numbers already entered, okay, so you've got some numbers already entered into a list, just arrow up to the top of the list and press the Clear button. Do not press delete, as that's going to delete the entire list, and you don't want to do that. So I'm going to go ahead and type in the temperature values. So the first column of that table, I'm going to put those numbers into the first column on my calculator. And all I'm doing is typing the number, and then I'm hitting the enter key after every number. Okay, so there's the first column of numbers. Now I'm going to arrow over to list number 2, and I'm going to enter in the rainfall numbers. Do the same thing. I'm just going to type in all the numbers, and after each one I'm going to hit the enter key. Okay, once I have all those numbers typed in, I'm going to go ahead and quit out of this stat screen to the main menu. So I'm going to hit second mode, take me back to my main screen. Now it says we want to draw a scatter plot of the data. So let's go like right here. You can see this first y equals button. Above that says stat plot. So I'm going to hit second y equals. I'm going to turn on this stat plot. And notice right now they're all listed as off. I'm just going to choose the first one here where it's highlighted. And I'm going to turn that plot. I can use this cursor and move it. I'm going to turn it on. Now there are different types of graphs that we can use. We can put whichever list that we want as the X and the other one as the Y. I'll just leave it as the default. It's going to make little boxes at all the points, and the color you can choose what you want. Now if you just hit graph, you're probably not going to see anything because the normal graph window is showing -10 to +10 in both directions. And I need to see the temperature and rainfall numbers, which are not in that negative to +10 range. So I'm going to hit this zoom button right here in the middle where I'm circling. And right here at the bottom, you see it says zoom stat. I'm going to arrow down to that option right there and hit enter. It's going to rescale the X and Y axis so that I can see all those data points that I put into the calculator at the start of this problem. So now I've got a scatter plot. So that's step 1. Steps 2 and 3 on that notes slide are to find the correlation coefficient and the equation of the line of best fit. So to do that, we're going to go back to stat. Okay, where we started by putting our information in. And across the top, you see there's some other things here. I want to go to this calculate menu. So I'm going to use the arrow key and go over to calculate. There's a whole bunch of things that we can do. Now right now in this unit, we're talking about linear functions. So we want to do this number 4 one, which is for linear regression. And notice that it's in this form. We're used to calling it mx plus b, but same idea here. This is like slope-intercept form right here. So I'm going to go down to number 4, hit enter. It's going to use the list 1 as the x, the list 2 as the y. You can leave that blank. This is a handy feature. I can tell it to put the equation into the y equals menu. I'm going to have it do that. So to do that, I'm going to hit the variables button. It says VARS. Here, I'll show you on the calculator. I'm going to hit this button right here. Okay, so when I hit that button, I get that menu. I'm going to go over to Y variables. I want to select function. I'm going to have it put it in Y1. Okay, so you'll see what happens when we do this. I'm going to calculate. And it's giving me an equation. Now, it doesn't look like an equation, but it's giving me a number for A, which I can replace the A with a number. So this is the slope. And it's giving me a number for B. This is the y-intercept. So I could replace the B with that number. And using these two numbers, I can write my equation of the line of best fit. Okay? Now, the correlation coefficient, that's the R. Okay, now this is not a statistics class, so we're not going to go into depth about how to do that. We're just going to let the calculator compute it for us. But I will tell you this, the closer that this R value is to 1 or -1, the more strongly the data is correlated. So I would say this is kind of it's not super strong, it's not super weak, it's kind of right in the middle. There's some correlation, but it's not super strong. Negative just implies that the line's going to slope negative. All right, if I go back to the y equals, notice what has happened here. The y equals, because I told it to store that line under y1, it's put that whole thing here. Now when I hit graph, I see the scatter plot and I see the correct line of best fit. All right, the final thing to do is to, and I want to go back, I want to see that equation again. The final thing to do is to predict the temperature when the average rainfall is 86 millimeters. So I'm going to leave the calculator, I'm going to go back to the notes slide, and we're going to work out that question number 4 there. Okay, I've just brought my calculator back into view so I can see the numbers on the screen. I know you probably can't, but we had it there earlier and the numbers are the same. So let's go ahead and check these off. The scatter plot, that was done on the calculator. We're not going to recreate that by hand. The correlation coefficient, the calculator screen gave me that. The R value is negative 0.7. Now even 7.0 to 2 decimal places. The equation, so I'm going to put the numbers A and B on the calculator screen into that equation. So I get y equals negative, I'm going to do a little bit of rounding, 0.35x plus 106.41. And then predict the average temperature, or the temperature when the average rainfall is 86 millimeters. Now in my calculator here, I had put temperature into list 1, which is the X. And I put rainfall into list 2, which is the Y. So this is a rainfall amount. This goes into this column of the table. So I want to know what's that value right there. So it's important to know where we are going to put that rainfall amount. And so we're going to put it into the Y variable. So I'm going to have 86, I'm using this equation right here. 86 equals negative 0.35x plus 106.41. And we need to solve this for the X. I'm going to do this on the calculator, and then I'll just write the answer. So we're going to subtract the 106, we're going to divide by the decimal. So if I do all that, I get an X value of 58.31, and that's degrees Fahrenheit. Okay, there you have it. That is scatter plots, line of best fit, using those to predict future values. We did it by hand. We also did it with the graphing calculator and walk you through the steps on how to do that. If you have any questions or comments, please feel free to leave them in the comment section below. If you found the video helpful, please give the video a thumbs up to support the channel, and I'll see you in the next video.